In order to find the inverse of a function, there's a couple things you can do. You can either do a do-undo table, which is what we practice a lot at the beginning, or you can just switch your x and y, where f of x is your y. So I'll do a couple of them each way so you can see how it's done. For number 17, if I'm doing a do-undo table, if I knew what x was, first I would multiply that by 8, so I'd multiply by 8, then I would subtract 9. So for doing, we move down. For undoing, we go up. So we'll add 9, which is the opposite. The inverse function of multiplication is division. So our inverse would be is x plus 9 divided by 8. So that'll be that inverse function for us. Now, 18, I will do where we switch our x's and y's and solve for y. So instead, this will say x equals 5, y minus 15. And again, what we're trying to do is we are trying to solve for y. So first, I need to divide both sides by 5. And I get x divided by 5 equals y minus 15. I'll need to add 15 to both sides. And I get y equals x over 5 plus 15. And that would be my final answer. I'll put, if we want to keep it, it needs to say the inverse of g of x is equal to x over 5 plus 15. So that one will really be your final answer there. This is how you would get there, but then your final answer needs to have that inverse. So for h of x, I'll do a do-undo table. I'll just go back and forth between the two. So to do, I would first multiply by 6 and then add 24. The inverse operation of addition is subtraction. The inverse of multiplication is division. So I would get the inverse of h of x is equal to x minus 24 divided by 6. For number 20, we will do switching our x's and y's. So we'll get x equals y minus 9 squared plus 1. First thing I'll do is I'll subtract 1 from both sides, and I'll get x minus 1 equals y minus 9 squared. In order to get rid of that squared, I'll need to take the square root of both sides. So the square root of x minus 1 equals y minus 9. Then I will add 9 to both sides. So I need to make sure I do the inverse. So that will be equal to the square root of x minus 1 plus 9. For number 21, one second. All right, for number 21, I'll do a do-undo table. Oh, it seems like I've run out of room. So we're going to do 21 on a sticky note. I'll do a do-undo table. So if we were solving this and we knew what x was, first we would multiply by 2, then we would subtract 5, then we would take the square root, then we would subtract 3. The inverse operation of subtraction is addition. The inverse operation of square rooting is squaring. The inverse of subtraction is addition. And there we go. So again, for do we go down, for undo we go up. So we will get inverse of k of x is equal to x plus 3 squared plus 5, and all of that needs to be divided by 2. Oh, that's kind of hard to see. Looks a little fuzzy. If you're having trouble seeing this, the answer key is online as well. So that takes care of 21. And number 22, I will switch my x's and y's. So x equals 4y squared minus 1. If I'm solving for y, I'm going to first add 1 to both sides, so we get x plus 1 equals 4y squared. Then I'll divide by 4, and I'll get x plus 1 over 4 equals y squared. And I'll take the square root of both sides. When you take the square root of a fraction, it's the square root of top and the square root of the bottom. So the square root of x plus 1 over the square root of 4, which is 2, is equal to, actually I'll write my equal on the other side. So the inverse of m of x. There we go. Ignore this little equal sign here.